All right, we're going to pull back the curtain on something pretty wild today. We're talking about the massive, totally invisible networks that are quietly running your social life. You know, the tech that connects you to friends and ideas in a way that honestly feels kind of like magic. But as you'll see, it's not magic at all. It's just some really, really clever data science.
You know exactly what I'm talking about, right? You open up an app and bam, it suggests someone you literally just met yesterday, or maybe a friend of a friend you haven't seen in a decade. How does it do that? Well, it's not psychic, but it's powered by some of the most sophisticated AI on the entire planet.
So, to get to the bottom of this, we first have to understand the actual shape of our online world. Because we're not just a random collection of people posting stuff. No, we're all part of this vast, interconnected universe. See, in the world of network science, every single user, that means you, is what they call a node. And every connection you have, whether it's a friendship, a follow, or even just liking a post, that's an edge. And when you put all those nodes and edges together, you get what's called a social graph.
And when I say these graphs are giant, I mean they're just mind-bogglingly huge. Just to give you an idea, the graph behind Pinterest's recommendation engine, it connects 3 billion items with, get this, 18 times billion edges. And that's just one platform.
So, how in the world does any computer make sense of a web that enormous? Well, you need a special kind of artificial intelligence. You need a brain that's literally built to think in terms of networks and connections.
And that's where the Graph Neural Network, or GNN, comes in. Its entire job is to learn from the shape of the graph. It looks at a node, looks at you, and all of your connections, and it distills that entire complex web of relationships into a kind of digital fingerprint. We call this fingerprint an embedding, and it's basically a string of numbers that perfectly represents who you are and your place in that network. Now, the way GNNs learn this stuff is where it gets really cool. They use a process called message passing, but honestly, you can just think of it as each node gossiping with its immediate friends. Seriously, it's finding out what the local neighborhood is like by just talking to its neighbors. It's a surprisingly human way for an AI to learn.
So here's how that gossip session actually goes down. First, a node gathers up all the info from its direct friends. Then it crunches all that information together to update its own fingerprint, its own embedding. And here's the kicker. It repeats this process over and over again. So information from friends of friends and friends of friends of friends all starts to flow in, creating an incredibly rich and nuanced profile for every single person in the network.
This is all amazing technology. Super powerful stuff. But there is a huge, huge catch. When you try to take these models out of the research lab and apply them to the real world, you slam headfirst into a massive wall. A wall made of data.
And this is where the gap is. See, in academia, GNN research often deals with graphs that have a few million edges. That's big, but it's small enough to fit on one powerful computer. Industrial graphs, like the ones at Snapchat, have tens of billions of edges. They are just way, way too big for any single machine to handle. To really put that into perspective, research from Snap showed that just storing the structure of the graph, we're not even talking about user features or the AI model itself, just the connections can take up 800 gigabytes of memory. Your laptop probably has 16. It's just a different scale.
And a research paper on this topic really nailed the core problem. The fundamental assumption baked into most of the tools out there is that everything can just fit on one machine. And that assumption completely shatters when you hit web scale. It's a massive engineering bottleneck.
But hey, engineers love a good challenge, right? To solve this billion-edge problem, they couldn't just tweak things. They had to completely rethink how you train a GNN from the ground up.
And that brings us to the hero of this story, a system developed at Snapchat called GGL, which fittingly stands for Gigantic Graph Learning. It's an open-source library that was built specifically to wrestle with these impossibly large graphs.
GIGL's secret sauce is a really clever strategy called tabularization. So instead of trying to cram that 800 gigabyte monster graph into one computer, it does something way smarter. It pre-calculates all those little local neighborhoods, the gossip circles, that the GNN is going to need. It's like pre-chopping all the ingredients for a giant meal so the final cooking is fast and easy. The whole workflow is just genius. GGL processes the raw data, does its tabularization magic, and saves millions of these little subgraph snapshots. Then, it can send those small, bite-sized tables out to thousands of computers to train the AI all at the same time. It basically turns one impossible task into millions of really easy ones.
Okay, that is some seriously impressive engineering, no doubt. But what does it all actually mean for you, the person using the app? Why go to all this trouble?
Well, it really boils down to this. The higher the quality of those digital fingerprints, those embeddings, the smarter, more helpful, and even safer the app can be for you. This tech is the bedrock for making your online experience better.
And its impact is everywhere. At Snapchat alone, Giggle has powered over 35 different product launches. It's the engine behind your friend and content suggestions. Yeah, but it also helps rank ads, and, this is really important, it's a key tool for detecting spam, abuse, and other bad actors, helping keep the community safe.
And the applications go way deeper than just product features. This tech can be used for something called community detection, which is basically uncovering hidden social circles and seeing how different groups form and interact online. It's almost like having a sociological superpower.
So in the end, by taming these absolute titans of data, we're not just building smarter apps. We are gaining a completely new lens through which we can understand the complex, hidden connections that shape our world. Which really just leaves you with one question, right? What else can we learn from them?